Okay, so we're continuing with the third lecture before lunch. So as you can see, it will be about OpenStack Cloud for Advanced Computing, and it will be held by Emir, so please welcome him with an applause.
Hi. So who here does not know what the OpenStack is? Perfect. Come on, there has to be more people. Okay, so my talk is going to be very different from the previous two ones, and I haven't prepared a demo. Though if somebody is interested, we can actually do it afterwards, because I probably won't have enough time, given that I like to speak a lot. I come from the Srce University Computing Center. I have been working there for 20 years, give or take, on the advanced computing. In summary, what we call the advanced computing, I'm actually head of advanced computing department. What we call the advanced computing is basically we serve the scientists and whoever has the applications which require a large amount of resources to execute. So basically a bunch of CPUs, storage, network, memory, and so forth. So here's briefly overview. I'll start with the project in which we established the resource which we call Vrančić. I will not go into detail why. And then I'll try to describe basically experiences, how we deploy it, some measurement that we performed on this particular resource. It has been on for less than a month now, so there aren't that many users. So even if I show some demo, there won't be too many graphs except what I did with the benchmarks. And then a few words about Ceph, future work, and conclusions. Please do stop me at any time if you have any questions. Who here has heard of Hrzo? Come on, people from Srce, put your hands down. It's embarrassing. It looks like I'm tweaking. It's like, oh, all of these people know. Yeah, they work for it. Anyhow, this is a large strategic project, one of three large ones, which started long time. Well, they were approved long time ago. Then they started in 2017, and then due to several setbacks, it took a little bit longer, not too much longer, and we finally finished it basically 11 days ago. So what is it about? The idea was we pulled the money from EU funds when we joined the EU in order to build a large national infrastructure for creation scientific and research community. Now, it has a bunch of different things. I will not go too many details, but basically we established 5 data centers. This whole project was led by Srce, but there were other partners, pretty much most of the universities, plus Carnet, and Carnet pumped their connection to 100 gigabit between cities. So if somebody is working on the institute that does not have 100 gigabit, it's your problem. But Carnet enables it now from city to city. Now the institute will be probably improved in the future, but that's their problem. Now finally the services. This is the thing that I've been working and together with my colleague was, in the end we established 3 services. One is the virtual data center. This guy is called Štampar. We use the names of famous scientists and educators. Štampar is educator. VDC is based on VMware. So it's a closed, it's a commercial product, so we're not talking about that one. But the idea is it's basically the cloud. So you put your VMs and your storage up there. It's fully redundant among all these 5 centers and so forth. My part is advanced computing, which does not care about availability. I only care about the capacity. So for us, it's just put as much CPU cores, memory, and other resources as possible in one place, and then just give it to users. So we have 2 resources. One is the HPC, again, a commercial product. So I'm not going to talk about that one today. And the other one is basically Vrančić, which is OpenStack plus Ceph solution, which I will describe to you now. There's also option to collocate equipment, but that's less important. Now, why do we have 2 of these in advanced computing? So HPC is for really large applications. So if you have something that you cannot run on a single computer, or you basically need to distribute it on like hundreds or thousands threads or processes, and then distribute it on, well, as many resources as you can get. With the cloud, it's basically the same thing. So you have a large application. You cannot run it on your laptop, mobile phone, whatever. And you need a bunch of resources. But you do not, for example, you do not need to allocate, I don't know, 1,000 core at one point and then distribute over them and then do the synchronization and blah, blah, blah. So you don't run something parallel, but for example, you run what we call loosely parallel jobs or embarrassingly parallel, which means if you're doing processing of images and you have a bunch of them and your application is basically single-threaded, so you just occupy as many of cores as you can get, but you do not care about parallelization. So that's basically why we have two of them. And as I said, the high throughput computing parameter sweep applications, loosely, embarrassingly parallel and so forth. So these kind of applications are really good for this because you just give them a bunch of cores. In theory, big data, machine learning, I mean, both of these things can fit in HPC and here, but basically they can fit better here, I would say. Interactive data analysis, with the HPC, you usually install machines and oh, I haven't seen you in a while. You install machines and you give people access via SSH. That's how the HPC is done. So your HPC, sorry. Is it better? Better. Okay, so for example, Euro HPC resources, they provide thousands of cores, and the access is always the same. You get the SSH account, you go there, they give you limited environment, and you can run whatever you're able to compile there. With this guy, you basically get the OpenStack, meaning you can deploy whatever operating system or set of services or whatever you want to run, and then you just run it. And that's another reason. So basically on HPC, you can just run what you're able to compile there. So there's a bigger amount of interactivity here and so forth. So it's based on OpenStack and Ceph, as I said. So a little bit about hardware. So we went for the high available option with the OpenStack. So this is like a recommended thingy, and with our size, 3 controller nodes were enough. And these guys are already pretty large, so there are 3 machines, each has 128 cores. I dropped the number, they have 7.68 terabytes NVMe drive for storing all the data that they need, so like stuff like monitoring logs and so forth. And it has 2 times 25 gigabit DC connection. Now the hypervisors, as I said, the idea is to provide people as many cores as possible. So we came to about 11,500 altogether, but there are 4 types, although there are 3 here. So there's 76 nodes with, this is the 3rd generation of EPIC. When we had a tender, the 4th generation was not out yet. And this is not the strongest one, so it's 2 gigahertz. The HPC has the strongest one, the one with 2.45. But anyhow, so each of these 86 has 128 cores, 500 gigabytes of RAM. At this point, we switched off multi-threading because it complicates things, but we might switch it on some nodes if people actually require it. Then the GPU nodes, altogether 16 NVIDIA A100 with 40 gigabytes of RAM on the machine, on the GPU card, and the machine itself has the same amount of RAM as the CPU nodes. And then finally, the big memory nodes, this is where you can run a VM which has 2 terabytes of RAM. We only have 2 of those, so we are not going to give them out lightly. All of them have the same processor, so if somebody's compiling, optimizing something, it will be easy. And all of them have 2 times 25 gigabit. Now the storage part, we split in 2 parts. So one is basically for the OS and for the people who were just going to stream a bunch of stuff there. This one is HTTP based. It has 6 servers altogether. Who here has tried to deploy Ceph? 1, 2, okay. Excellent. So this one is HTTP based. You'll recognize that it has the NVMe SSD because of the database and a log thingy. While on the HDDs, you actually store the data itself. While the fast storage is purely NVMe So it's basically flash-based, but it only has 3 servers and, well, 3 times 9 times 15.36 terabytes, which basically altogether the upper one gives 3 petabyte brutto, and the lower one is about 400 terabyte brutto storage. The lower one has 4 times 100 gigabit. But since we got the NVMEs are actually PCI Gen 4, which I did not expect that we will get. And basically the throughput that you can push through these drives is actually higher than the throughput that you can get through these Ethernet channels, unfortunately. But it still, the Ceph, the OSD you cannot get that much speed anyway. So the 4 times 100 is really good enough. So this is how it looks like. Has anybody been to the new DC on campus, other than people from Srce? It's really cool. It's the 1 megawatt data center that we established as part of the Croatian Zoo project, Hrzo project. And it's basically the largest DC, the largest academic DC in the country. And currently it's pretty empty. We basically have this row, and in the back there's a replicated one. There's a warm area inside, and the supercomputer is basically just behind the back of the photographer. It's just one rack. Okay, so the numbers around 11,500 cores, 16 GPUs, bunch of RAM, and these should be netto storages, the amounts, and the Ethernet. Now, I think in 2019 I gave a same speech, but at that point we haven't finished installation, so I was just doing a little bit of theory. At that point the service was called HTC Cloud, and we finished it a little bit after the DORS conference. And it has been running now for a while, but it has way less resources than this one. So it's altogether 600 CPU cores. It's the first generation of AMD EPYC, and way smaller than this one. So altogether, I think it has 450 terabytes of stuff. But basically, when we established this one in 2019, we had, well, years, obviously, to gain knowledge on how to work with these systems. And in fact, when we built this DC, they forced me out of the old one, so we had a week to move the old system. You cannot see it on the picture, it's in the other row. It's basically just one rack compared to the 8 racks that the current system occupies. So they gave us 1 week, and we managed to migrate everything without downtime. Because the replica on the Ceph was configured to 3, so basically you put the minimum size to 1, and basically at that point you risk if the one that you leave online, if it dies, then you lose the data. But, well, it took us it was actually 4 days, 4 times 24 hours. And we managed to migrate everything without the people noticing that it was down, which was a really fun experience. So deployment, it's total 100 servers, so it makes no sense to do anything manual. So we basically rely on the tools that we have been using at Srce for quite a while now. So first thing, when you have 100 or over 100 servers, you need to manage the remote consoles and the configuration of BIOS. So we use because everything is HPE based, there's a really cool tool called ILREST, which you can then use to do configuring where to send the emails in case of problems, where to send the logs, and you can actually do firmware upgrades to this thing, and it works pretty well. You basically just do 4 and go through all 104 of them and do the upgrade while you're having lunch. Now, the installation of the servers, we use Cobbler. Has anybody used Cobbler in the room? People from Srce, keep your hands down, please. There's another guy who ran away from Srce. So it looks something like this. So you just define, I want this gateway. You need to pull the MAC addresses because it's DHCP based. And then you configure a bond, you put the IP address, you define a profile, and it basically installs like a minimum OS. I mean, you can do really complicated things with it, but for us, we have the second step, which is Puppet. And then, has anybody here worked with Puppet? You like Puppet or Ansible more? What are we here? More Ansible or Puppet people? I saw a lot of Puppet hands. I'll conclude you all like Puppet more. So anyhow, so this is just a bit. But basically with this thingy, I configure that you need to do, so the system that we use for installing OpenStack is Python based, so you just define the requirement file and just put this in the Puppet, and then your 104 servers suddenly become OpenStack ready, not OpenStack enabled yet. The PSSH, pretty cool thing if you want to run on 100 servers the same command. Before we were using C3 tools, but they kind of died in the meantime. And then with the network, LATSP, because it's two connections, and the LLDP is really useful when you have so many servers. Because when you say, I want to add another VLAN or something like that, the networking people will immediately ask, can you send me the output from the LLDP command. Now, the networking measurements, so if you use just one stream with the 2 times 25, we were able to get this, like 20 gigabits. And that's why you need to use multiple streams, because LATSP will work over streams. And we got on the normal servers pretty close to 50 gigabits, which is 2 times 25. And I really like this one. On the storage ones, you get really close to 200 gigabits a second. Now, the OpenStack itself, we installed with Cola. Why Cola? When we did it in 2019, the 0002 just seemed too complicated, although I think it's still supported and people use it quite a lot. But I don't know, this one was just easier. You just do the installation of Python thingy, and it uses Ansible. Just to bootstrap the Docker containers, and then you can integrate it with the existing Ceph. You don't have to use this one to install a Ceph, and there are some, you need to put the Docker repository somewhere so you can modify it and so forth. So we use our local GitHub instance for that. Now, whoever has worked with the Ansible will recognize this thingy. So you define here the category, well, the roles for the set of machines, and then additional parameter which override the default ones which you put in another file. I would need a whole day to explain all the bits and pieces, but let's say you just need to put this thing, and in theory, the other thingy you don't even need to modify too much. You have to put the few host names of your private and public interface and so forth. And then you just do the run deploy, run reconfigure. You can limit if you want to reconfigure just one box. Otherwise, reconfigure over the whole cluster depending on what you do. But for us, with the optimization, like you do parallel SSH sessions and so forth, it takes about 20 minutes. Sometimes less, sometimes more. So if you want to change just one tag, then you use the tags, or just change one node, you limit only on one node. With the GPUs and NVMe drives, the PCI pass-through was a bit of a struggle because there are several documentations online, but we actually hit a bug with the Docker containers for Z version. They immediately fixed it, but that took us some time, but in the end, the PCI pass-through works. So basically, the idea is you give the whole device to the VM, and then you lose it on a hypervisor level. Unfortunately, if anybody knows what the MIGs are, so basically the capability of which started with the A100, that you can partition the NVIDIA, the GPU device. It does not support PCI pass-through. I was really hoping for that, but unfortunately you need to buy the vGPU licenses to actually cut your GPU into little pieces. And the NVMe namespaces I did not manage to do pass-through with them. So basically you need to pass the whole thing up there. If somebody has managed to do any of these things, in theory the NVMe should support the three of, but that thing also I did not manage to make work. With regard to the network performance, so we use the VXLAN, so the standard thingy, and the external network provider. So the single VM, even with multiple streams, basically caps at 20 gigabits a second. But then if you use the same hypervisor and you deploy multiple VMs, in this case, this was with the 3 VM, I got up to 5.35 gigabytes, so that's around 43 gigabits a second, which is close to 50, close enough. So with regard to the Ceph, we use the Blue Store. On the previous one, we were using File Store because the NVMe devices that we put in there were not large enough because they require you to put it at least 4% of the size of the data disk, and we did not have that much. Because when we were doing the first tender, the Blue Store was not out yet. The first one we deployed with Ceph Deploy, which was really easy. Now we did use the Ceph Orchestrator, which is also very easy. You get cheap the Prometheus monitoring, which is pretty cool. And we split the network. So I said it has 4 interfaces. So 2 of them are bonded for access from the machines, and then 2 of them are bonded for the cluster network. So for the synchronization between the boxes themselves. Now the standard storage one, we use size 3. So replica, we did not want to play around with the erasure coding. So we lose a lot of storage, but you're really happy when you can just crash like half of your machines and your Ceph is still working. And then the fast one uses size 2, and there was a discussion whether to use 2 or 4 OSDs per NVMe. We went with the 2 at the end because the 4 one did not give significant performance results. So this is how the Ceph status thingy looks like. So as you can see, 168 OSDs, and the other one was 3 times 9, I said, and then times 2 because we run 2 of them per NVMe. So some performance. So we run a file over 10 hypervisors. We did not use the OpenStack. We just mounted directly the RBD on the hypervisor. So we run over that, and with the HDD, I did not reach even 10 gigabytes a second, so I'm not particularly happy with that, but that's the number that we got. While the SSD gave me the numbers which are fine, so 23 gigabytes for write and 55 gigabytes per read. And there was 1 million IOPS random read, which also should be larger, but I just couldn't get it more than that, so we'll see somewhere in the future, maybe we will increase that. Future work and conclusion. So the VF flag and SRIOF are really cool things. And when we deployed the first one, we did not play around with it because I said the hypervisors have two connections which we bond, which basically means you cannot pass it through to the VM. But with the new ConnectX Mellanox cards, you can use the VF flag thingy, which basically allows you to create the virtual interfaces, the VFs, and then you bond them, and that bond you pass up there, and in theory you get the basically line rate speeds. I tried to do that, and the documentation is even worse than the pass-through one, and I did not get. It's not working yet, but I'm gonna get there. We're gonna improve the monitoring. Right now, the Cola comes with the OpenSearch and the Prometheus thingy, which brings you the similar thingy that you've seen on the presentation before. So you get the Grafana and dashboards and so on, blah, blah, blah. That's all very nice. We also monitor the hypervisors with our in-house solution and so forth. And then we need to deploy new user services. So because our users are scientists, researchers, so we do not really expect that they'll play too much with the OpenStack. We just need to deploy something for them, and then they will play with that. In conclusion, we have been running this for, I don't know what's 23 minus 19, but, well, let's say 4 years, give or take. It has its perks, problems. In theory, it's easy to use if you do not change things too much, and it's flexible if you are capable of reading code and have some experience. You don't have, I mean, for example, I don't use Ansible outside of this thing, and it's really easy to learn. And we pretty much rely on what the people sitting at the end of the row provide us in Srce, so pretty much a bunch of in-house tools which are supported, and they all work very nice. And that's it. Thank you for your attention. Here's a link to the service, and here's the mail where you can contact us, but you can ping me as well after the meeting, after the presentation. Was that on time? Questions? I don't have T-shirts. If a question is, if I, Well, the question was why did we use ill-rest and not ironic? These are two completely different things. In theory. We did not use ironic because we do not want to give the whole machine. We do not want to provide bare machines to people. And that's why so the whole thing, it does not even have ironic enabled. We didn't want to enable it at all. Well, I mean, it would if we would want to provide, if we would, it's just that we do not want to provision bare metal machines. So we didn't have a need for it, and that's why we didn't even bother to install it. I mean, the Ironic does the same thing that the Cobbler thingy does. So since we already had Cobbler, we relied on that. And Ilores doesn't do any provisioning. It's just pure, it's basically a tool which uses the ILO API to configure like BIOS or like what? It's, I don't know what that is. Ah, no. The ILRest is something which is really specific for HP. This is something similar to ASU that IMB/Lenovo provides, or something similar to, I can't remember the name, there's something that Dell provides for IDRATS consoles. Yeah, they call it IDRATS, but that thing is called somehow differently. I can't remember the name. So all of them provide, because there are other tools. There's the SUM thingy that HP provides, but that is horribly slow. And I tried and it didn't like it. And this thing is, you just install one package and you can easily configure. I mean, it's limited in capabilities. I wouldn't. It's the whole thingy. So the whole thingy is deployed on just one DC. Yes, but I do not have. Yes, but did you hear the beginning? In my case, I do not care about the availability. I just care about the capacity. So my users, I do not expect that somebody is going to put the API there. No, we have the other service for that. So the Stampar service is actually deployed on all 5 of them. And it does the automatic, so if like somebody drops a bomb here, it will automatically take over and put things here, and then you can do, but exactly, so, but there you cannot do advanced computing, so. Yeah. I just do computing, and it's really cool. Like, for example, 2 weeks ago, we had a disaster where the whole DC went down, and it's basically the people just rerun things. Yeah. Yes. So question is why not Terraform? Because these 2 things were already there. But the Terraform in which capacity? What would you use the Terraform for? In this whole story? As far as I know, Terraform does not do deployment of bare metal machines. But you mean like why we use OpenStack at all? That's your question. That's why you use no. That's why you use the OpenStack. With the OpenStack, you say OpenStack server create, and then the creation of those machines. That's not my problem. Because that's the problem. No. I mean, I'm kidding. But well, this is the thing. I provide the infrastructure, and we automate the infrastructure part. So Terraform does not work well there because we have a bunch of bare metal machines that you need to set up. And we did that part. And now what you're saying In theory, somebody could use the Terraform over the OpenStack client and run whatever they want. It's their problem then. Because this is the freedom the OpenStack gives you. So you have the API, you have the CLI, you have the GUI, which I really don't like, but you have all three of them, and what you do with them, it's really up to you. I don't know. Okay. You have more questions? As I said, unfortunately, no T-shirt. Okay, we'll allow somebody else. Yeah. So the question is why Ceph? The answer is why not? No, I mean, well, to be honest, I mean, we were not the first people who deployed this. This combination is quite popular, and there are several of them in the centers that do the same thing as we do. And this combination is basically all of them, they're using it. I mean, you lose a lot of store. I mean, we wanted to go with the open source solutions because just I like to do that, and I want to spend all my money on machinery because that's what I do basically. As colleague mentioned, I don't care about the availability. So it's just buy me as many courses as possible, and that's what my what my users really like. I mean, if I tell them this is highly available, they'll just say, yeah, but you gave me only 10 cores. What do I do with that? Anyhow, so the Ceph thingy, I haven't even check the alternatives. I mean, in theory, one alternative could be that you just do the NFS server and then deploy something in the backend, some kind of distributed file system like BGFS or Lustre or something like that. But I don't know, this thing seemed the easiest way, and the people have already been using it, so we can basically ask those people, what are you doing when you have this, this, and this? So let's say we kind of relied on the experience of others. So the question is, have you ever had to do the Ceph recovery from disaster? The answer is no. As I said, we had to migrate it, which basically means we had to drain nodes and then do it on the other side. We had a disaster a week ago, but it's not the proper one, like the one that you're describing. I know that the Greek story, that they had the worst one, and luckily, we haven't had that problem yet. But yeah, I kind of hope we will hit it one time because it will be fun to see what do you do. But we haven't yet.
Great. Thank you, Emir.